One of the things we need to be able to do is we need to figure out when trig functions are positive, because you need to know whether your answer is going to be positive or negative. And so let's just start with sine. Sine is the y value. Now the y value is positive in the first quadrant, the second quadrant. It's negative in the second, the third and the fourth. So sine is going to be positive in the first and the second. All right, now let's go to cosine. Cosine is the x value, and the x value is positive in the first and the fourth. It's negative in the second and the third. So cosine is going to be positive then in the first and the fourth. And then tangent is y over x. So for it to be positive, I either need the positive divided by positive, or I need a negative divided by a negative. So tangent is positive in the first quadrant or the third quadrant. So then as we're looking, sine, cosine, tangent are all positive in the first quadrant. Only sine is positive in the second quadrant, tangent's positive in the third, and cosine's positive in the fourth. So you can always remember it by just thinking through x and y and all those things, or you could remember this saying that we use A for the first quadrant, S for the second, T for the third, and C for the fourth. And so the saying that they have going with this is they say that all students take calculus. So as you go around the XY axis here, you can just follow along and say all students take calculus. So then as you're trying to figure out if something's positive or negative, you can use that saying to help you remember which quadrant that works in. So here's an example of what we're going to use and do this. So we're first told that tangent is negative 5/4 and cosine is greater than 0. So we're looking at cosine being positive. So what we're doing is we're trying to figure out which quadrant we're talking about. So this could be anywhere in all four quadrants. So I first set up my triangle talking about tangent is negative. Now tangent is positive in the first and the third, so that means tangent is going to be negative in the second and the fourth. Now I can't have both triangles. I need only one triangle to do this. So then I go to my next piece of information that cosine is positive. Remember, cosine's the x value, and so it's going to be positive in the fourth quadrant. So it is not going to be positive in the second, so we can get rid of that one. So that means we are only working on this triangle in the fourth quadrant. We can put our angle in there, and then we fill it out. So tangent is opposite over adjacent, and so then we have to figure out our hypotenuse using the Pythagorean theorem. We get 25 plus 16 gives us 41. So the hypotenuse is going to be the square root of 41. And now we can find sine. Sine is opposite over hypotenuse. And then if we multiply top and bottom by the square root of 41, we get negative 5 root 41 over 41. And then secant, okay, secant is going to be the hypotenuse over the adjacent. And then we don't have any rationalizing to do because the square root's on the top. So there's our answer for that one. All right. Next topic is talking about something called reference angles. We've actually been using reference angles quite a bit. So when we want to talk about an angle that is here, the angle is really way too big to make triangles. So what we do is we say, let's just look at this angle in here, this little one, and use the x and y values for that. Well, this little angle right here is called our reference angle. And technically, we can't use theta for it. Technically what we do is we use theta prime. So we just put this little tick mark on the top of theta just to say, you know, this isn't the real angle, but it's our reference angle. For example, if I am looking at the angle 210 degrees, so that would be right there, 210 degrees. That's the full angle. Angle equals 210 degrees. The reference angle, though, is, hold on. The reference angle is in here, and this is 30 degrees. So that reference angle is 30 degrees. And then we can use that on the unit circle to figure out our sine, cosine, and tangent. All right, so we're just using some more trig identities here. So let's see here. Theta is in the second quadrant, so we can draw our picture, second quadrant. And the reason that's good for us is not so that we can use a triangle, but it's more just so that we can know whether things are positive or negative. Now sine is 1/3, and we're trying to find cosine. So we're supposed to use trig identities. So we're not going to use this triangle until we're talking about positives and negatives. What we're going to do is we're going to use our trig identity. We know sine, and we're trying to find cosine. So our trig identity we're going to use is sine squared plus cosine squared equals 1. So if sine is 1/3, we plug in 1/3 and square it, plus cosine squared equals 1. When we square that, we get 1/9. I'm going to subtract 1/9 from both sides. So then cosine squared equals 8/9, and we square up both sides. So we get cosine theta equals, now we're looking at the square root of 8. 8 is 4 times 2, so we get 2 square roots of 2, over the square root of 9 is 3. But now we have to go back and we have to figure out, is this positive or negative? Now remember, we're in the second quadrant. Cosine is the x value, and it looks like the x value is negative here, so our answer should be negative.